Okay, guys, so now it's the final question where we algebraically find the formula for the inverse function. Now, before I get into these final questions, all of these questions are algebra, so you're going to be given blue books for these things. You don't have to bring your own graph or scrap paper. I'm going to give the person who's proctoring you blue books, and you'll answer in those. Uh, you still will have to have your computers off, your calculators have to be able to turn on, you'll have to have your working pens, and you'll hand in your blue books. There's going to be a few different versions of the exam, so you got to hand in both the blue book and put inside the blue book the exam sheet with your name on it, so I know which version of the exam you're doing. So that's all vital. Okay? And so remember, bring your books, print out whatever notes you need because you won't be able to use the computers. Computers will be off, calculators on. So remember, you must have the computers so that you must print out any notes you intend to use. Okay, this, by the way, is the same formula as this. This is not an accident. I decide if it's good for one, it'll be good for the other. So we're going to do question 3 now, and all of this will appear in your class notes too, by the way. So question 3, this is, okay, so we're going to find the inverse. So we're going to start by saying we're going to take y, g of x, we're going to rename it y. Or f of x is going to rename y. This is an f of x problem. And we're going to say, not f of x, sorry, f negative 1 of x. We're going to rename that y. So that now when we say f of y, f negative 1 of x, that's going to equal f of y. But that's still equal to x. And what's that going to mean? Well, now I take the formula, 7 minus 6y. You put that in math mode. 7 minus, parentheses, 7 minus 6y divided by 9 plus 3y is going to equal x, and since it's a since the left side is a fraction, we make both sides a fraction. Remember, when two fractions are set equal to each other, they get angry because no fraction ever wants to be equal to any other fraction, so we cross multiply. And that's going to give us the formula 7 minus 6y times 1, which is 7 minus 6y, is going to equal x times 9 plus 3y. But we distribute the x, and that gives us 9x plus 3xy. So far, so good. And I'm going to make sure we don't run out of screen space on that. Good. Now that we have this formula, we're going to move all the terms that have y to the left side and move all the terms without y on the right side. So we're going to have, I'm going to subtract 7, and I'm going to subtract 3xy from both sides. So at this point, grabbing my pen that I put unhelpfully far away, these 7s, the 7 and minus 7, and the 3xy's, both will cancel. And what I'm going to get is minus 6y minus 3xy is going to equal 9x minus 7. Now I'm going to factor out y so that I only have one y. I'm going to get y, and it's going to factor out from minus 6 minus 3x equals, still equal to 9x minus 7. Now we divide both sides by minus 6 minus 3x to get the y by itself. So we divide the whole thing, minus 6 minus 3x, not part of it. And that's going to tell us that f of x, f negative 1 of x, which equals y, which we got by itself now, is going to equal 9x minus 7 divided by minus 6 minus 3x. And that is the answer to the formula for the inverse function. Now we're going to verify by doing f negative 1 of f of x. So we got to do f negative 1 of f of x. And so we're going to take 9 f of x minus 7 and divide that by negative 6 minus 3 f of x. Now we're going to plug in the f of x form. We're going to replace it with the f of x formula. So what I'm going to do, I'm going to copy this guy like this. Only instead of f of x, we're going to replace it with the original formula up here, up in the original problem. 7 minus 6x over 9 plus 3x. So we're going to put in 7 minus 6x divided by 9 plus 3x. Okay. And so this is actually going to turn into 9 over 1 times that. And this guy is going to become 7 over 1. And this guy doesn't need his parentheses on top. He picked up the parentheses. Let me just turn that into straight 7 minus, no, don't do that. Okay, now that's right. Now, I'm going to get 6 minus 6 minus 3 times f of x. Now, I already got the f of x formula here. Let me just see if the thing is willing to pick it up there. And I'll just replace f of x with his formula. But once again, I got to change all my integers into fractions. So that turns into 3 over 1. And this guy becomes minus 6 over 1. So now I'll do the numerator multiplying. So 9 will multiply by this guy, and I'll get 9 times 7 is 63. Not 4, 3. And 9 times 6 is 54. So that's what happens when I do 9 times that. The 1 multiplies very easily. This becomes 3 times 7, which is 21, minus 3 times 6, which is 18. So that gets rid of the 3. Now, what we got to do now is common denominator these guys. So, the common denominator on the top is going to be 9 plus 3x, and on the bottom, they're always the same. So this is going to be 9 plus 3x over 9 plus 3x. And down on this side, this is the guy who needs the 9 plus 3x. And down here. And now we have on the top and the bottom common denominators. Just to make sure, I'm just going to go like that. And now I'm going to multiply this by 7. So 7 times 9 is going to turn into 63. And 7 times 3 is going to turn into 21. And down here, negative 6 times 9 is going to turn into negative 54. Oops, negative 54. And negative 6 times 3 is going to turn into minus 18. So, the 63 minus 63 on the top is going to cancel. And the minus 18 over here is going to cancel. And so what we're going to have is on the top we have 54 minus negative 54x minus 21x is going to turn into negative 75x. This whole thing is going to turn into negative 75x on the top. And on the bottom, the 18s will cancel. Negative 54 minus 21 turns into a regular, no x, minus 75. Now, the 9 plus 3x is a factor. They cancel. The minus 75s cancel. So all that's left at the end is x. And that is the answer to question 3.